Identity as a service moves identity control into the cloud and, in doing so, changes where trust is established and enforced. Instead of identity systems living entirely inside an organization's own infrastructure, authentication and authorization decisions are made by hosted platforms that sit at the center of many access flows. This shift reflects how work actually happens today, with users, devices, and applications distributed across networks, locations, and providers. The security implication is that identity becomes the primary perimeter, and the identity platform becomes one of the most critical control points in the environment. Understanding how identity as a service works and how cloud identity and access management builds on it is essential to managing modern access risk. Before we continue, a quick note. This audio course is a companion to the CISS books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Identity as a service platforms typically provide authentication, authorization, and directory services as hosted capabilities rather than as software you install and manage yourself. Authentication services verify credentials, enforce multi-factor requirements, and apply risk-based controls. Authorization services evaluate roles, attributes, and policies to decide what an identity may access after authentication succeeds. Directory services store users, groups, and attributes, acting as a central source of identity truth that applications and services can rely on. Because these capabilities are delivered as a service, availability, resilience, and provider security practices become part of your threat model. The benefit is scalability and rapid feature evolution, but the responsibility is ensuring that hosted identity controls are configured and governed correctly. Cloud Identity and Access Management governs access to cloud resources using identities, roles, and policies rather than traditional network boundaries. In cloud environments, access to compute, storage, databases, and services is controlled primarily through identity-based permissions. Instead of relying on where a request comes from, cloud platforms ask which identity is making the request and what that identity is allowed to do. This model aligns naturally with distributed systems and automation, but it also means that identity misconfiguration can expose powerful capabilities instantly. Cloud identity and access management is therefore not a niche concern limited to administrators. It is the core security control plane for cloud environments. Errors at this layer often lead directly to data exposure or resource compromise. Identity providers are the engines behind both identity as a service and cloud identity systems, issuing tokens and assertions that applications and services trust. When a user or workload authenticates, the identity provider evaluates credentials and policy, then produces a cryptographically protected artifact that represents the result. Downstream services rely on those artifacts rather than re-authenticating the user themselves. This delegation simplifies application design and centralizes enforcement, but it also concentrates trust in the identity provider. Protecting signing keys, enforcing proper validation, and controlling token scope and lifetime are therefore foundational requirements. When identity providers are well governed, they enable consistent access decisions across diverse services. Central directories within identity as a service platforms synchronize users, groups, and attributes across environments, creating a unified identity view. Many organizations maintain identities in multiple places, such as on-premises directories, human resources systems, and cloud platforms. Synchronization ensures that changes in one authoritative source propagate to others, keeping identity data consistent. This is particularly important for joiner, mover, and leaver events, where delays or inconsistencies can lead to excess access or orphaned accounts. Synchronization also introduces dependency chains because errors or latency in one system can affect access everywhere. Managing these directories requires attention to data quality, attribute ownership, and conflict resolution. Conditional access is a defining feature of modern identity-as-a-service platforms, evaluating context signals before granting authentication or establishing sessions. Rather than making binary allow or deny decisions based solely on credentials, conditional access considers factors such as device health, location, risk indicators, and user behavior. Policies can require stronger authentication when risk is elevated or block access entirely under certain conditions. This approach aligns security with real-world variability, acknowledging that not all access attempts carry the same risk. Conditional access also allows organizations to reduce friction for routine activity while maintaining strong controls for sensitive access. The effectiveness of conditional access depends on accurate signals and carefully designed policy logic. Role assignments are how identities are connected to cloud permissions, translating business intent into enforceable access rules. A role represents a set of permissions, and assigning a role to a user, group, or workload grants those permissions within a defined scope. This abstraction simplifies management, but it also requires discipline to avoid overly broad roles that violate least privilege. In cloud environments, roles often control powerful actions such as creating resources, modifying configurations, or accessing sensitive data. Clear role definitions and controlled assignment processes are therefore essential. Without them, role-based access becomes a shortcut to overexposure rather than a structured control. Least privilege in cloud identity systems depends on scoping roles carefully to specific resources, actions, and conditions. A role that is appropriate at one scope, such as a single project or resource group, may be dangerously broad at a higher scope, like an entire tenant or subscription. Conditions can further refine access by requiring certain attributes or context to be present before permissions apply. Achieving least privilege requires understanding both what actions a role permits and where those permissions apply. It also requires resisting the temptation to use broad, built-in roles for convenience. Least privilege is not automatic in the cloud. It is a design outcome that must be pursued intentionally. Privileged cloud roles require stronger controls because they can alter identity systems, security settings, and infrastructure at scale. These roles often include the ability to create other identities, assign permissions, or disable safeguards, making them high-value targets for attackers. Strong authentication, just-in-time access, and approval workflows are commonly applied to these roles to reduce standing privilege. Monitoring and alerting are also critical because misuse of privileged cloud roles can have immediate and widespread impact. Treating privileged cloud access as a distinct risk category aligns cloud identity practices with broader privileged access management principles. The objective is to make high-impact actions rare, deliberate, and observable. Application Programming Interface Permissions are a special case in cloud identity because they grant programmatic access without human interaction. Applications and automation often authenticate using tokens or certificates that allow them to call cloud services directly. These permissions can be extremely powerful, especially when they are granted broadly or without expiration. Narrow scoping is essential, limiting application permissions to only the specific actions and resources required. Ownership and lifecycle management are equally important because unused or forgotten application permissions can persist indefinitely. Managing application programming interface access with the same rigor as human access is necessary to prevent silent, long-lived exposure. Tenant configuration becomes a security boundary in identity-as-a-service and cloud identity platforms, defining the outer limits of control and trust. The tenant holds identity data,
policies, roles, and integration settings, making it the container for the entire identity environment.
Administrative access to the tenant effectively grants authority over all downstream services that rely on it. As a result, tenant-level administration must be tightly controlled, monitored, and reviewed. Misconfiguration at the tenant level can undermine every application and resource connected to it. Treating the tenant as a high-value asset clarifies why governance and access control at this layer are so important.
Audit logs are one of the strongest advantages of centralized identity platforms, capturing sign-ins, policy evaluations, and administrative actions in a single place. These logs provide visibility into how identities are used and how access decisions are made over time. They support incident response by allowing analysts to trace suspicious activity back to specific identities and policy outcomes. Audit data also supports compliance and governance by demonstrating that controls are enforced and reviewed. The value of these logs depends on retention, integrity, and integration with monitoring systems. When audit logs are actively used rather than merely stored, they become a powerful security signal.
Federation is a common pattern in identity-as-a-service deployments, linking on-premises identity systems to cloud services without duplicating passwords. In this model, users authenticate to a familiar internal identity provider, which then issues assertions or tokens that cloud services trust. This reduces password sprawl and centralizes authentication control, while allowing organizations to adopt cloud services quickly. Federation also creates dependencies, because availability and security of the on-premises identity provider affect cloud access. Proper trust configuration, certificate management, and monitoring are essential to keep federated access secure. When managed carefully, Federation supports hybrid environments without weakening identity assurance. Identity-as-a-service and cloud identity systems shift security emphasis toward policy design and administrative control rather than network placement. Authentication, authorization, and directory functions are centralized, making configuration correctness and governance critical. Roles, scopes, and conditions define what identities can do, while conditional access adapts enforcement to changing risk. Privileged roles, application permissions, and tenant administration concentrate power and therefore demand stronger controls and visibility. Audit logging and federation provide integration and traceability across environments when implemented carefully. In this model, cloud identity security succeeds when policies are deliberate, administration is tightly controlled, and identity is treated as the primary security boundary rather than a background service.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.